burn like a pro.
Let's think about our planet's atmosphere for a second. Imagine it's this huge, unbelievably complicated, and perfectly tuned chemical engine. For millions of years, it's just been humming along in this state of perfect balance, the very balance that makes all life here possible.
But here's the thing about a high-performance engine. It's sensitive. And any unwanted stuff that gets in there, whether it's from a volcano or a factory, it's basically like throwing grit into the gears. It messes with that delicate balance and threatens to throw the whole system off the rails.
So what really happens, chemically, ecologically, when the gears of this atmospheric engine actually start to grind and clog up? Well, that's the big question we're going to dig into. To really wrap our heads around the problem, we've got to start right at the source. We need to look at the specific pollutants, the actual grit that's gumming up the works. And it often starts with something we see every day. Just think about the exhaust coming out of a car or the smoke from a factory. By itself, one puff of smoke might seem like nothing, but when you add it all up, that's where some of our biggest problems begin. So here are some of the main offenders. Let's take carbon monoxide, or CO. It gets released when fuel doesn't burn completely. And the scary part is it loves to bind to the hemoglobin in your blood, which basically starves your body of oxygen. Then you've got sulfur dioxide, SO2, which comes from burning coal. This stuff is the main ingredient for acid rain, which can absolutely wreck entire ecosystems. The point is, each pollutant has its own source and its own unique way of causing damage. So faced with these kinds of threats, we did what humans always do. We engineered a solution. But as we're about to see, these fixes, well, they often come with their own set of tricky trade-offs. A perfect example is the catalytic converter in a car. It's this incredible little device. Inside, you've got this ceramic honeycomb that's coated with really precious metals like platinum and rhodium, and its whole job is to take the really nasty pollutants coming from the engine, like carbon monoxide and nitrogen oxides, and, through a chemical reaction, turn them into things that are much less toxic right away. But, and this is a huge but, here's the catch. We solved the problem of toxic smog choking our cities. Great. The trade-off? We turned those pollutants into carbon dioxide, CO2. So we basically took a local air quality problem, and by fixing it, we made a much bigger global problem worse. We just kicked the can down the road, or I guess up into the atmosphere. And this is where we have to zoom out. We need to look at the bigger picture, at the huge planetary system our actions are messing with, the global carbon cycle. Now, in its natural state, the carbon cycle is this beautiful balancing act. Think of a scale. On one side, you have things that release CO2, like us breathing out or a forest fire. On the other side, you have things that absorb it, mostly plants doing photosynthesis and the oceans. For thousands and thousands of years, these two sides were in perfect balance, which kept CO2 levels in the atmosphere nice and steady. And that balance gives us the natural greenhouse effect. That's actually a good thing. It's like a thin blanket that traps just enough of the sun's heat to keep Earth from being a frozen rock. But by burning fossil fuels, we've been pumping massive amounts of extra CO2 into the air. And now we have an enhanced greenhouse effect. We've basically swapped out that thin blanket for a super thick, heavy duvet, and it's trapping way too much heat. And all this trapped heat doesn't just make things a little warmer. Oh no. It kicks off this massive domino effect, this chain reaction of consequences that ripples across the entire globe. For starters, a whole lot of that extra heat gets soaked up by the oceans. And warmer oceans, that's like high-octane fuel for tropical storms. It means that the hurricanes, typhoons, and cyclones that do form, they get stronger, more intense, and way more destructive. Next up, let's look at the poles. The glaciers and the ice caps are melting much, much faster than they can refreeze. And this is a double whammy. Not only does it cause sea levels to rise, which is a huge threat to coastal cities, but it also means we're losing these massive frozen reservoirs of fresh water that millions of people depend on. And finally, there's this hidden chemical crisis brewing in our oceans. A big chunk of that extra CO2 just dissolves right into the sea, and that forms carbonic acid. This whole process is called ocean acidification, and it makes it super difficult for animals like corals, crabs, and oysters to build their shells. It's literally dissolving the very foundation of entire marine ecosystems. So let's tie this all together. We started this whole thing talking about a single car engine, and we've ended up at a full-blown global crisis. So how does it all connect? It really all comes back to one thing: our reliance on burning fossil fuels. This one single action triggers 3 different kinds of crises on 3 different scales. Locally, right in our cities, it creates smog. On a regional level, it causes acid rain. And then globally, it leads to the whole planet trapping too much heat and becoming unstable.
And that right there is the key takeaway. Air quality isn't just a bunch of separate problems. What we do locally creates these enormous reactions on a planetary scale. It's all connected in this one huge, deeply entangled chemical web.
And that, of course, leaves us with one last really important question to think about. If all the problems are this interconnected, what does that tell us about the kinds of solutions we need to be looking for?